Not bio again. Okay, who's that? You only speak this one. See, you guys will see each other again. It's okay, you guys will always see each other again. So, we'll start off today. We're gonna do a bit of integration today. Yeah, we're gonna work through my bit of the integration stuff. Is this yes? Okay. And I'm just gonna say this now. You guys are never gonna run out of questions because this is by far the longest worksheet that I have. It's so long. Because calculus. Well, the integration one was one of the first worksheets I made. So, yes, expect some difficulty in what you will see. Because yeah, I probably should watch the video. Oh, well. Okay. So let me open this one up. Remember to have your formula sheet with you while you do this. And we will... Where is the formula sheet? It's on the VCAR website. So let me just screen share the window. If you need a copy of the formula sheet, it should be, if you go into VCEA, mine comes up with VCEA chemistry, but if you go to the VCEA, yeah, you click curriculum, so this is the main page, you click exams and examiners reports, going all the way to mathematics, we go to methods, and then click on formula sheet. So I'll have this one next to me for the whole time. We're gonna have to remember this whole section plus a couple formulas. So let's have a little bit of a look at this. So I mean, this first question here isn't too bad. So it says here, let f of x be between negative pi to pi, where f of x equals 2 sine of 2x, take 1. Calculate the average rate of change of this function. Now, this isn't related to integration. However, they usually put integration and differentiation, like they most likely will put them next to each other in some way, shape, or form. They sort of go hand in hand with one another. So, I will ask. I'll ask Rishab, what is the average rate of change formula?
F of B minus F of A of B minus A.
Yep, so what's B in this case?
5 over 6.
Yep, and then A is just negative pi on 3. So then we have here pi over 6 take negative pi over 3, which is just going to be, well, here we're going to evaluate these on the side. So we have here f of pi over 6 equals 2 sine of pi over 3, take 1, which is just going to be equal to 2 times root 3 over 2, take 1, which is just root 3, take 1. We also have here f of negative pi over 3, which is just 2 sine of negative 2 pi over 3, take 1, which is just 2 times negative root 3 over 2, take 1, which is just negative root 3, take 1. So that means here, we're going to have here root 3, take away 1, take negative root 3, take 1, over pi on 6 plus pi on 3, which is just pi over 2. We get here root 3 take 1 plus root 3 plus 1 over pi over 2 is just, if we cancel out these ones, we just get 2 root 3 over pi over 2 equals 4 root 3 pi. So that's our average rate of change, yeah? Now, obviously, I've done a lot of working out there. It's worth 2 marks, so you probably don't need to do as much as I've done. But I've just formulated it in this. I've just formulated in this way for more or less demonstrative purposes. The main thing that I'd focus on really is being able to simplify this one into this one, and then this one directly into this one through quick working out. Yeah. That's like the main, that's where I would try and save time, is with those individual steps, because these ones over the side, they don't hurt too much, the timer. So here, Sway, do you know the average rate of change formula?
1 over b minus a integral of ab or ba.
Yeah, AB, f of x dx. So it has to be, yeah, so integral from, so I'll phrase it as the integral from a to b. Yeah, that's the phrase that I'll use. Yeah.
Alright.
So here, what is going to be your a and b for this?
Pi over 6 and plus pi over 3.
So pi over 6 plus pi over 3, integral from neg pi over 6, pi over 3. Yeah, you would have missed the average rate of change one. You guys should go back and watch the recording, because it's literally just the first part of this. Sine of 2x take away 1 dx. Now, from here, what I usually... Yeah, go on, Salam.
Isn't it? Actually, no, never mind. Sorry.
What's up, Swayhan?
I'm not.
Oh, what's up, Swayhan?
I was gonna say, isn't it pi over 6 at the top and then negative pi over 3 at the bottom?
Yeah, that's an
Because
incredible point. I read this completely wrong. Yeah. So it's pi over 6, pi over 3. My bad. So we get this one. So here we can simplify this outside into 2 over pi equals the... And then we can evaluate the inside of the integral. So if we evaluate this inside of the integral, we get here... well, the integral of 2 sine of 2x is just going to be negative cos of 2x, take x, from pi over 6 take pi over 3. Now, what you can do from here is you can do 2 pi equals f of pi over 6 take f of negative pi over 3. So this is just the fundamental theorem of calculus, right? So if I do here f of x equals negative cos of 2x take x, we do here f of neg pi over 3, we'll evaluate that one. So here, what happened to the 2 at the front? The 2 at the front, so remember the integral of sine is minus cos of 2x, but then we have to divide it by 2, as shown on the formula sheet. So if we look at the formula sheet over here, I've just preemptively divided it by 2. Do we need the plus c? We don't need to put the plus c in this one, because this is a question with boundaries. If it didn't have boundaries, you'd have to put the plus c in. So from here we get cos of negative 2 pi over 3 plus pi over 3. This can be simplified into cos 2 pi over 3, which is just negative cos 2 pi over 3, which is just here. So this is negative positive a half, because here we get cos of negative 2 pi over 3 is negative a half, but there's a negative at the front, so it becomes positive, plus pi over 3. We also have f of pi over 6, which is just negative cos of pi over 3, take pi over 6, which is negative a half, take pi over 6. So then we can plug this one into here, so we get here 2 pi brackets 1 over 2 plus pi over 3, take brackets negative 1 over 2 take pi over 6, which is just going to be equal to 2 pi brackets 1 plus pi over 2, and here we can just say the answer is 2 pi plus 1. So, does that process make sense to everyone? I'm just using that average value formula, right? And substituting all the values and then evaluating the integral from there. Yeah? So these ones, like, I'm going to say this now, probably take your time with integration, because there's unless you're very strong with integration, you're very likely to mix it up with diff, right? That's what people tend to do. They'll accidentally differentiate the function instead of integrating it. I know I've done that a lot. So does that make sense to everyone? Thumbs up, thumbs down, thumbs to the side. For Rashab and Joe, I know you guys weren't here, but it's more or less, it's the same. It's like you still use the integration techniques that we've learned, but we're using a formula now. Yeah? So I would recommend to go back and have a look at that formula, because we'll also be using a lot of stuff in the bounded areas. So here, right? This question's always an interesting one, right? Did you cover Newton's method? I did. Newton's method was covered in differentiation. This is confusing. Can I go back to watching the motivational videos about my game? So here we have this question. I missed. So here, let x be a continuous function. We're not going to be worrying too much about the probability density function part about it. I'm more interested in this show that. So it says here, show by differentiating that x to the power of k squared brackets k ln of x take away 1 is an antiderivative of x to the power of k take away 1 ln of x, where k is a positive real number, right? So I don't care too much the probability density function part. I'll ask Mia, yeah? How can we differentiate this top function?
Would we have to use the product rule?
Yeah, product rule. So what is u equal to here?
K, x to the k over k squared.
Yep, and what is v going to be here?
K ln x minus 1.
So then what is, so you write down du on dx, but this means the same thing as u dash, right? So what is u dash going to be?
Do I have to use the quotient rule for that?
So here, remember this is x, we're differentiating in terms of x, yeah? So it's just a, it's just the power rule. So it's k x take away 1 divided by k, because we multiply it by k, yeah?
Mm-hmm.
Does that make sense? And what's the derivative of dv on dx?
Is that 1 on k?
So it's k over x, because the derivative of ln is 1 over x, and we multiply by k. Is that all good?
Mm-hmm.
So then, right, we can then say d on dx of x to the power of k over k squared, k ln of x, take away 1, is equal to, right, we use the quotient rule here, we have here k, x to the power of k squared, we have here k over x, plus, here we have here k ln of x, take away 1, times by k to the power of x take away 1 over k. I'll ask Swayam, how do we simplify this one?
I didn't do it like that. That's not how I did it. I did it a different way.
How'd you do it?
So I did u equals to, well, x to the power of k over k squared, and I just did u dash equals to kx to the power of k minus 1 over k squared.
Kx minus k over
No, like kx, yeah, like that.
of
And
k
then
squared, yeah?
I just did the derivative of log, which is k log e x minus 1.
So k log e x minus 1. So
And then I just put them together.
yeah. So what do you mean times? So times the two
So
functions.
like, No, I use like the product rule, like u dash by v plus v dash by u.
Ah, okay. So you still use the same rule here. We're both using the same thing, yeah?
Yeah.
So here, right, do we see that this one can simplify down to k x take away 1 over k, right? This is what you need to know. You guys need to know your index laws. I know a lot of you guys like drop the ball on index laws. Don't drop the ball on index laws. They're very useful to know, yeah? And if we expand the brackets for this one over here, this one, right, this can be written as k x take away 1 over k brackets k ln of x take away 1. We can expand out the brackets for both of these, and we get here k x take away 1 over k plus, right? Here, if we expand the brackets, we cancel out the k at the bottom and the top, and we get k x take away 1 ln of x take k x to the power of k take away 1 over k. We can see these two cancel out to each other, and what we're left with is that k x take away 1 ln of x equals xk over k squared ln, oh wait, brackets, k ln of x take away 1. Remember to d on dx it is equal to this, which means, how can we rewrite this as an integral expression? Mia was the only one in the call yesterday. Mia, how can I rewrite this as the integral expression?
It was integral of, would it be of the k to the x over k squared k ln x minus 1?
So it'd be the other side. So it'd be here, the integral of k take away 1 ln of x dx is equal to k to the power of x k squared k ln of x take away 1. Yeah? So the integral expression is just the reverse, right? If this is the derivative, of this function, that means this is the integral of this function. I mean, wait, no, this is the integral of this function over here. I respect the dedication. So, does that make sense to everyone? Dude, I wish you guys were here. We might have had too much fun yesterday. Does that make sense for Salam? Does that make sense for you, Swayam? Because I know you will. Okay. So, yeah. A lot of you guys missed yesterday, and yesterday, like, this is probably one of the, I would say, the hardest technique, mostly because it's like, it's more about, oh yeah, can you recognize that the derivative of one function is also, it can be rewritten using an integral, yeah? So I won't worry about this part because you haven't done the probability density functions, but yeah, we won't worry about that, which change. So here, we're told, given that dx e to the kx over dx equals brackets kx plus 1 e to the kx. How can I find this integral here? Remember, okay, first here, what I do is I first rewrite this as an integral expression. So I essentially just do e to the power of kx plus c equals the integral of kx plus 1 e to the kx dx. Yeah? Then what I do from here, right, I can see, I can then expand out these brackets. So I can get here kx e to the kx plus e to the kx dx equals x e to the kx plus c. Yeah? Now I can see that this one looks very similar to what I want. Yeah? That's what recognition's about. It's seeing which one is very similar. And I want to isolate that one by itself. So here, right, to isolate it, I can first expand out that integral. So I can expand out that integral like this. Yeah, remember the integral can be distributed to each part. And then what I can do is I can see, well, here I can just take out this k and I get exactly the integral that I want. So then I can subtract both sides by this integral here. Yeah? So here I get x e to the kx, take the integral of e to the kx dx, k integral x e to the kx dx. Yeah? And then I divide both sides by k, I get 1 over k, x e to the kx, take integral e to the kx dx, integral x e to the kx dx, and I get d as my answer. Does that make sense for everyone? So salam, it's chill. What about everyone else? Is everyone else lost? I am. Mia, Daniel, Rashad, does that make sense for you guys? Okay. So the only annoying part, I think this question's a bit annoying in the sense of it writes your final answer with an integral. Yes, you can subtract an integral from both sides. I remember this was a very hard concept for some people to understand, but you can subtract an integral from both sides. Because like you can technically rewrite this in a different way, right? And it would look a little bit more like answer option E, but the thing is, you have to, if it's a multi-choice question, you have to try and get into the form of the multi-choice. Yeah. So I already knew it wasn't going to be A or C, so it has to be one of B, D, or E. So I'm just trying to manipulate it to get into that form. It's a bit like this one. Like this is why integration by recognition probably needs some of the most practice. So here, right? We have these two. And it says, consider the graph of the function f and g shown below. The area of a shaded region could be described by. So, I'll ask Mia. I'm sorry, Mia. I'm like being like, I'll ask you because none of these other guys were here. So, here, how could we write this as an integral? Or how can we write the shaded area as an integral? How can we break it up into two separate regions? Maybe.
You'd want the integrals to have like the different domains.
Yeah. So what domain would you want the first integral to have? Like what?
0 to b.
So 0 to b, maybe, right? Does the top function and the bottom function change?
No.
No. So they try and trick you here by putting this b. So what do you think the first integral would be?
Oh, the 0 to d.
So it's gonna go all the way from 0 to d, yeah? So is that the how would you write that integral? So from 0 to d, yeah?
And
What
then
function?
f of x minus g of x.
F of x. It's not g of x, because g of x actually doesn't go from 0 to d. It goes from a to c, yeah? So we have an integral of f of x. Then we take away the integral from a to b of f of x. I mean g of x, sorry, dx. Because we can think about it as this integral here represents this total area, yeah? And here, if we take away this integral, it's going to represent this area. So here, what we're left with is just going to be, well, whatever we've got in between. It's going to be all of this stuff, right? So here, we get answer option E as our final answer. Does that make sense for everyone? I'm breaking it up into different areas, yeah? I'm breaking it up into different areas. So here, like, here you need to more or less, that's why I always tell you, that's why I always, like, want you guys to make sure you really visualize what area you're looking at. What does the integral, how can we write the integral in relation to the area? That's why we always want a graph for these, yeah? So, actually we haven't dealt with this one. We'll look at this one a little bit later because the integration transformation is a bit interesting. But here, I'll ask Swayam, how can we do this question? How would you approach this question here? It says here, part of the graph of the function f, where f of x equals negative x squared plus ax plus 12 is shown below.
I would do the integral of from 0 to 3.
So the integral, so here,
Check there,
0 to 3,
and make that equal to 45.
so it's equal to 45. So remember, I need the dx. So here, because we're told that the shaded region is going to be equal from 0 to 3 is going to be equal to 45. We're told that by the question. Yeah, let me rewrite this in a little bit of a nicer way. So here it's 45, integral from 0 to 3, f of x dx. Yeah. Then here we'll have 45 equals the integral from 0 to 3 of negative x squared take, wait, is it plus ax? Yep, plus ax plus 12 dx. Yeah? So from here, right, Rashab, how can I integrate this function?
Negative x cubed over 3
Yep.
plus a x squared over 2 plus 12x. Yeah. And then you have to do it for 0 and 3.
Yeah. So then here, I'll write this over here. So that means 45 equals f of 3 take f of 0. This is just the fundamental theorem, and I'll evaluate this f of, so I'll put f of x over here as negative x cubed over 3 plus ax squared over 2 plus 12x. So we get f of 3 equals we get negative 27 over 3 plus a times 9 over 2 plus 36. So if we add these one together, we get negative 9 plus 9a over 2 plus 36, which is just 9a over 2 plus 27. And then we get here f of 0 is just 0. Because here, if we put 0 in for all of these, we get 0. So we get here 45 9a over 2 plus 27 take 0. So then here we're just left with 9a over 2 plus 27 equals 45. So then, Joe, if your mic works, how can we solve for a? Oh, your mic doesn't work? Oh, I'll ask Salam then. Salam, how can we solve this one?
You take 27 from both sides, which will be 18 equals 9a on 2.
Yep.
And then you times by 2 on both sides, which will equal 36 equals 9a. And then you divide by 9 on both sides. So a equals 4.
So a equals 4. So we get a equals 4. So are we done with the question? It says here, find the value of a, m, and n. Right? We have n and m over here, which are the intercepts. So here, I also have to find the intercepts of this function. So here we know that f of x is now equal to negative x squared plus 4x plus 12. If we try and do f of x equals 0, we get 0 equals negative x squared take 4x take 12. And we can factorize this one and see that it's negative x take 6x plus 2, which means that x equals negative 2 and 6. So I'll ask Mia, what is the value of n and what's the value of m?
N would be negative 2 and m would be 6.
Yeah, so here that means a equals 4, n equals negative 2, and m equals 6. Yeah, that's 5. That's a 5-mark question. I'm just gonna say that now. So that's an eighth of your paper. So you guys are seeing a general trend here. Yeah. I'll say this now. I'm showing you very hard integration questions. That's one part. Yeah. The second thing is that, well, integration. They will try and test the hard parts of integration. That's one thing that they'll try and do. And two, you will have to create. You have to create an abstraction or some sort of formula using the stuff you know from integration. Yeah. So this is where I would say integration is probably the topic which differs the most from the textbook. Yeah. So this is where doing exam style questions for integration is absolutely pivotal for you actually being able to do the integration in the exam. You need to recognize that the exam standard of how they approach integration is very different from the textbook standard, because the textbook's just trying to teach you the basic skills. It's not like differentiation where they go really in detail with the diff. Yeah. For integration is just as it is, right, in the textbook. It's just the integration, but it doesn't show you any of the problem solving. That's why I'm doing the exam style questions today, yeah? Because I was like, okay, well, I'll show these guys the diff and I can show them basic skills, but then they're going to get all confident, right? I don't want you guys to be overconfident. I want you guys to realize this is the, like, this question is probably one of the hardest they'll get you to do in exam 1. Exam 2, I can think of one of them, like, one question in there, and it's, like, so annoying. Yeah, you got to keep us humble. There you go. Cool. So here, using your calculators, right? How can I find the average value of cos of x over the interval from 0 to pi on 2? I want to see who remembers that formula. I want you to see who's A, B, C, who picks A, B, C, and D. Yeah, as in CAS. Yeah, you have CAS. If it's a multi-choice, it's exam 2. All multi-choices are exam 2. So that's just a definite thing for. Oh, everyone here uses the black calculator, if I'm correct, right? No one here uses the white one. I don't think I know. Oh, I don't. You don't know the function? Oh, the function on the, oh, you don't know the CAS function. Okay. So did anyone else get an answer for this? Sharp got D, yeah? Anyone else? D. Is Daniel just saying D? Is he just following along? What about everyone else? Joe, Salam, Mia, Swayam. What did you guys get? Got D as well. Yeah. That's not my D. Okay. So here, if I screen share my CAS, this is what the CAS notation should look like. I'm just plugging in the exact formula, yeah? So here it'd be 1 over pi over 2, take 0, equals, times by the integral from pi over 2, from 0 to pi over 2, cos of x dx. So that's what I'm doing. And I can find that by doing menu 4, 3. That's where the integral option is on the CAS. So I'll return back over to here. So this one's interesting. So let's see who remembers how to find the bounded area. So it says here, the total area of the shaded region in the diagram is given by. So what do you guys think the answer is? Is it A? Is it B? Is it C? Is it D? Is it E? What do you guys think? I kind of kicked you guys into the deep end. One of you guys got E, okay? Someone got B. Someone got D. So another person got D. There's usually a neither E. There's usually never E. Oh yeah, no. E isn't on the exams anymore. So here, right? The answer is not A. A will find you the total signed area. The answer here isn't going to be B either, because, right, the boundary isn't from 0, right? We don't actually, like, here, the boundary from 0 doesn't actually help you with anything. And, like, this whole integral here, right, what it will do is it will make this area positive, but it won't consider the signed area from these parts over here, yeah? So we want to remember the signed area of the whole of these parts. C is wrong, right? Because C assumes symmetry. You cannot assume that the graph is symmetrical, yeah? Because it's assuming that this area and this area are the same size. You can't assume that. Unless the question tells you, you can't assume it, yeah? So that's why C is in the answer, right? This integral, the other issue with this one is that this is negative area. So here, if we do +2 times this integral, we'll get negative area over here. So now we have here E and D, right? So we want to tell the difference between E and D. Now here, I'll say the answer here is D. And I'll explain why E is wrong, yeah? It's because it switches the terminals, yeah? If it switches the terminals, right? Essentially, if we switch the terminals, that means the exact same thing as -1. So I'm just writing out the integral. Obviously, there's the rest of the function and the dx part. I'm just going to write out the integral for the time being, yeah? But if we write out the integral, that's equal to negative the integral from the opposite boundaries, yeah? I want you guys to remember that property. I remember it like I outlined that property as one that you need to know, yeah? You need to know that property. So here, it's almost like we switch it and it becomes negative. But here, right, this area is going to be the negative version of this whole area here, right? And if we negative it again, right, we're just going to make it positive. We're going to make it negative because we have negative area, which has already been made negative by flipping the boundaries, which we're making negative again by putting a negative sign at the front, yeah? The same thing occurs over here as well. Because here, they've switched the terminals. So by switching the terminals, we made it negative, right? So that means we have negative area, and we're making it negative, which means we're making it positive. And then we're going to put another negative at the front. So here, the answer for this one is D. Does that make sense to everyone? Does anyone have any questions about that? I'll say this now. This integration worksheet is to completely humble anyone who thought integration was really easy. Yeah? Like the actual integrating itself isn't too hard, but it's the thinking that goes behind integrating which is hard. So, we won't worry about this question here. Yeah, we won't worry about this question here. And we won't worry about this one either. Yeah, we won't worry about this one. I think I've already given some of you this. This is from the 2006 exam 2. And this is the last question on the 2006 exam 2. I would recommend having a go at this question. It's very interesting. If you get it right, I'll be very interested. If you get it wrong, I'll also be very interested. But have a go at this one, because like the reason I don't want to fixate too much on this one is because a lot of this isn't even functions. I mean, a lot of this isn't even integration. Most of it is just like functions and how they work, and then the last part's integration. So if you're able to get all the other parts right, you can get this. You can get part F right. Should have gone with my gut. So here, right? We saw this one yesterday. Mia, do you remember seeing this one yesterday? Can you explain how we find the normal equation again?
We found the derivative, and then when x is 0.
Yeah, so here, what's the derivative of this function?
Is it e to the x over 2 over 2?
Yep, over 2. So then, what point are we subbing in?
0.
Yeah, because it says here it's a normal, the normal of the graph where it crosses the y-intercept, right? So where it passes the y-intercept is when x equals 0. So here I get 1 over 2, because here we get e to the power of 0 divided by 2. E to the power of 0 divided by 2 is just e to the power of 0. And e to the power of 0 is just 1. So we get 1 over 2. So then how can we find the gradient of the normal line, Mia?
Put that in -1 over a half.
Yeah. So here we're just using the formula m perpendicular equals -1 over m o. So I'm saying the OG one. So the tangent line is the OG one. Yeah. And we're going to use the OG one to find the perpendicular. So we get here -2, and then I'll do the rest of this one. So here we get this point as 0, 2. If we find out f of 0, it's going to be 2, because we get here e to the 0 over 2, which is just plus 1, which is just e to the 0 plus 1, which is the same thing as 1 plus 1, because e to the 0 is just 1. So we get here 2. So we can use our y take y1 equals m x take x1, and we can just plug in all these values. Now, do you see here that a lot of the time I'm ruling a line down my page? It's because I want to work down in maths. I want to work down the page, yeah? So if I work down the page and I rule a line through it, I can then just use this other half when I need to, yeah? So here I've ruled down. I need to use the other half, so I'm using an arrow to point up that I'm going back to the other half. And now I have y take away 2 equals -2 x take away 0. So I'm just plugging in all those points. And I get here y take 2x plus 2 as my solution. So it says here, I'll ask Swayam. It says here, find the exact area of the shaded region. How can I find the exact area of that shaded region?
Would you just wait? Can you just go up a little bit, please?
Yeah, sure. So I'll show you the whole thing.
Would you just do is it just the integral of, like, it's f0 and x0 by -2x plus 2 minus minus the actual one, if that makes sense? That makes sense.
Not quite, not quite. So
Um,
I'll ask you, what's the boundaries of this because we know we have to use an integral here, yeah? What are the boundaries of this integral?
I don't know. It doesn't give it to you. It's just 0 and something, right?
Yeah, it's 0, but look at this point. What is this point?
X something.
It's the x-axis intercept of this normal line.
Oh, so 2.
No, it's 1.
Oh,
So
wait. Oh, yeah, my bad,
So
yeah.
here, this is x equals 1, yeah? But
Yeah.
what if it's not touching just by here we have to trust the diagram, yeah? Like they'll say the diagram is not to scale if they mean it like that, yeah? So here we have our integral boundaries. So here a equals the integral from 0 to 1. Now I'll come back to Mia, right? How could we find the bounded area between two functions?
Do we have to let it equal the derivative?
No. So that's the recognition one. Not quite. Do you remember top minus bottom?
Oh, yeah.
Yeah. So we have the top curve minus the bottom curve. So we have here f of x take away the tangent line, which is just going to be negative 2x plus 2 dx. So that's what that's the full expression that we get here. So if we substitute in our values, we'll get here a equals, now there's a reason I rule the line down the page, is because this is going to take up a whole lot of space. So we get here 0, 1, e to the x over 2 plus 1, take away negative 2x plus 2 dx, which is just equal to the integral from 0 to 1, e to the x over 2 plus 1 plus 2x take 2 dx, which means here we're just left with this integral from 0 to 1, e to the x over 2 plus 2x take away 1 dx. So here, Salam, what is the integral of the inside here?
Is it just e to the x on 2
Yep.
on, actually no, 1 on 2 e to the x on 2 plus x squared subtract x?
So the first part you got wrong because you accidentally differentiated it. So you look at the formula sheet when integrating. So here
Oh yeah.
we get 2e to the x over 2 plus x squared take x. You got this last part right, from 1 to 0. Yeah, then we're going to just say a is equal to f of 1 take f of 0. We'll go down here, we'll say that f of x equals 2e to the x over 2 take x squared, oh wait, plus x squared take x. We'll do f of 0 equals 2, right, because we have e to the power of 0, right? E to the power of 0 is just 1, so we get 2 times 1, which is just 2. Yeah, and then x squared take x becomes 0. And we have a f of 1, which is just 2 e to the half plus 1 take 1, which is just 2 e to the half. Hence, a equals 2 e to the half take away 2. And that's my final answer there. Does that make sense for everyone? Does that make sense? Thumbs up, thumbs down, thumbs to the side. So I'm just doing the area this is me applying the area calculations. So we've done recognition, we've done the average value, we're doing a bit of the area calculation, the bounded area calculations. You do have to trust the diagram here. I'm going to say this now. For integration, if they give you a diagram, you do have to trust the diagram. Now, I know a lot of the time people are encouraged not to trust the diagram because we're told it's not to scale. But here, for integration, they have to draw it to scale. It's simply unfair to the student if they're told to not draw it to scale. So, here, right? I've seen that I can either calculate the area. I can use the area. Wait, let me scroll back up here. I can, determine the area by breaking it up into its different signed areas, right? I've seen that I can use an integral to write a formula, yeah? A formula, and we know that what the area is equal to, and we know what the integral is. We can equate them to one another. So we're able to write equations with the integrals, yeah? Another thing that we can do is we can break it up into multiple parts. And we use integrals to represent what those multiple parts are, right? So we want to find the green area. What is menstruation? It's just isn't it just the formula measurement section? That's what we call it. That's what it's called. It's called menstruation. It's just the formula. It's just the formulas for different shapes and different areas. I was just confused. And then here we see how we can use derivatives to create integrals. Yeah? So do you see there's a trend with these, yeah? There's a trend. It's either going to be focusing on area calculations or it's going to be focused a lot on this integrals creating derivatives. There is also we are given the derivative and we want to find the original function once. That's the third part. But we see these two already coming up a lot. A lot about areas, yeah? Integration, as I said, when I first started talking about integration, is the study of areas, right? Obviously, there's other ways to conceptualize an integral. For example, I can conceptualize it using vectors, but we're not going to talk about that. So here, the area of the the area of the region bounded by the curve with the equation y equals kx to the half, where k is a positive constant, the x-axis, and the line with the equation x equals 9 is 27. Now, I said this the other day. We always need a sketch for these. So, a sketch of this function is going to look like this. We always need a sketch. This is what our sketch of this function is going to look like, because it is a square root graph where k is positive, and it's going between the x-axis. So our boundary here is the x-axis and the line x equals 9. And we're told that the bounded area between this curve, the x-axis, this curve, my bad. I accidentally mixed up the x and y-axis. This is the x-axis. The bounded area between this curve, the line x equals 9, and the x-axis is equal to 27. Yeah? So, Swayam, what equation or what formula or what can I use to find out the value of k?
Can you just do the integral from like 9 to 0?
So the integral from 0 to 9, yeah?
Yeah, sorry, 9. And then just kx squared.
Kx to the half, remember?
Oh yeah, sorry, my bad.
Dx, yeah? And then what can we do?
Then you solve it. Like then it becomes then you take out k. Like k is just by itself, and then it's like square bracket x to the power of 3 divided by 3, and then the integral from 9 to 0.
Okay.
Does that make sense?
So here, right? Why are you writing this integral though?
What do you mean?
Like you're writing the integral out, but like, why? Because it's just sort of sitting by itself.
But we're trying to find the area, so won't you write the integral?
We're told the area.
Yeah, but wait. We're not told the area.
We're told the area is 27. And it wants us to find k.
Oh, but like, don't we need to find, like, we need to have k in something and then make that equal 27?
Yeah. So that's what I was looking for. You want to make it equal 27.
Oh, I was just trying to do it by itself and then make it, because I get confused if I do it all together.
Oh, okay. So then what you can do is you can like, we can mostly forget about the 27 and just deal with the integral. So that makes sense. That makes sense. Yeah. So here I'll put the dotted line through it again. Yeah. So here now I have 27 equals the integral from 0 to 9 kx to the half dx. How can I find the integral of this one, Rashad?
Is it kx to the power of 3 over 2 over 3 over 2?
3 over 2, yeah. From 0 to 9, which means here this integral is going to be equal to 27 2 kx over 3 over 2 over 3 from 9 to 0, yeah? And hence we can use... Who is trying to join? Here. Yeah, I'm not admitting that person into the call. I had people come into the chemistry one the other day. Yeah, bro, you remember that. Yeah, no, I'm not accepting people into the call unless they have messaged me. They're told to message me if they want to join. If they don't want to join, then they can, or like if they want to join but they don't want to message me, then you know, they can stop themselves. Let them in, trust. I want to see it firsthand. But I'm good, bro. I had to edit that recording and fix it. I fix it myself. It's really irritating to fix. So here, right, we then can use our fundamental theorem of calculus. So we have f of 9 take f of 0, yeah? And here, we'll write it up here. So we have f of x equals 2kx to the 3 over 2 over 3. We know that f of 9 is just going to be equal to 2k over 3, 9 to the 3 over 2. Rashab, what is 9 to the power of 3 over 2?
Root 9 to the power of 3.
Yeah, root 9, wait, sorry. Yeah, what's root 9?
3.
Um,
So 27.
Yeah. So that's what I was looking for. So it's kx times by 27 over 3, which is just, if we cancel these this 27 3 out, we're just left with 18k. Yeah? So we get 18k over here. Now we also have f of 0, right? I'll ask Daniel, what is f of 0? What is f of 0 here? What's f of 0? Yeah, f of 0 is just 0. So we have a f of 0 is just 0. Don't worry, I wasn't looking for anything like too crazy. Yeah. So yes. Why isn't it working? Okay, I guess my stuff didn't work. Anyway, just have this one here. I'll close this and I'll get this. So we get here 0. So that means here we know 27 is equal to 18k take 0, which means that k is just equal to 27 over 18, which means k is equal to 3 over 2. Does that make sense for everyone? Is that all good? Thumbs up, thumbs down, thumbs to the side, thumbs all around. So see, I'm just using my knowledge of integration to don't say that. Don't say after this, bro. What's that? God forbid, bro. God forbid. So, how can I use my calculator? How can I use my calculator to find out what e to the power of k is? How can I use my Casio calculator? My Cas calculator. My calculator. Algebra solve? Yeah, sure. You can use algebra solve. Menu 4-3, menu 3-1. So tell me what you guys think the answer option is, and then we'll discuss it. So here, what do you guys think? So Mia's got an E. Mia's got an E. What does everyone else think? Anyone else got any answers? Anyone else got any last calls, final bets? Final bets, A. Wait, what's integration on CAS? Menu 4-3. Menu 4-3. So I got Salam got A. Anyone else getting A? Anyone else getting E? Someone choosing another answer option? Wait. So A. Okay. So for this one, right? I'm gonna screen share screen. So this is the whole screen over here, right? I have the integral. I have this so k is equal to this integral. So I can literally just substitute in this whole integral up here. and I can plug this whole thing into my calculator. Yeah? And I get here, answer option E. I get answer option E. Yeah, incredible call, incredible call. So that's what we get here. Yeah? What about this one? What is the average value of the function y equals tan of 2x over the interval from 0 to pi over 8? Right? What is this average value of this function? So try and use your calculator to find out that average value of the function. What does your calculator tell you? Because I know, like, what's it called? Because if someone told me to put the average value of what's it called? If someone told me to do this one by hand, I'd be able to do it by hand, but you guys can't do it by hand. So I'm cool like that, you know? I know how to do all of this stuff by hand. I'm epic. But why would you do it by hand when you have a perfectly good calculator? Okay. Okay, another smoke. Because you don't know tech onk. So we get EA. What do you guys say? D. Long formula. So if you use the average rate of change formula, you would have gotten the wrong answer. I think you would have gotten 8 over pi if you use the average rate of change formula. So you would have gotten answer option E. Here, if I show off my CAS calculator, right? This is what my CAS calculator says. I plugged in the formula, I put in the function, I put in the boundaries, and I've got here answer option A on this one. So we get answer option A for this one. What is upsilon?
On the CAS, why do you need the stuff like that's on the left of the integral sign?
The left, that's how we find the average value. So the average value formula is, so the y average is just equal to 1 over b, take away a, the integral from a to b, tan of 2x dx, right? B must be equal to pi over 8, a is equal to 0. So that's how we get the stuff on the left.
Yeah.
So that's the
Yeah.
formula. Where do you get your online CAS from? It comes with the calculator, guys. Like, here's my CAS. It comes like in the CAS, like right there. You can't use this one because it's mine, and I've already like done it. But like, I bought a second hand one. No, it's not a teacher. No, it's not a teacher student. Like it's like genuinely you can download the CAS software. Don't get it, obviously. You don't need it, right? Use the CAS that you have in front of you, right? Because that's the thing that you take into the exam. I'm gonna use that one because I need to show it off to you guys what I'm doing. Yeah? So this one. Okay. So here. So here we're showing these two questions. We're showing F and G. And we're showing the point 1,6 lies on both of these functions. So total 1,6 lies on both of these functions. So, Mia, when you're given an exam question like this, what do you normally do?
Define the function.
Yeah, you define the function. But don't try and do this. Don't try and do this if you don't define it, because it's going to be a pain in the ass to do this. So here, if I screen share the whole screen, like so, we get here menu 1,1. We get f of x equals 6 sine of pi x over 2. Yeah, so we get f of x equals times pi x over 2. You get 1, 1. We also can type in here let me just use my pen for this. G of x equals, here we have the function, we just type in 2x cubed take 6x and then plus 8x. So we get these are our two functions, yeah? We want to find the maximum of f, right? It says find the value of a for which g of x has a maximum, right? We can either use our trig theory to do this, or we can use our calculus, right? Go on, Swaya.
You put 6x at 6x squared for gx.
That's an incredible call, bro. Holy incredible call. I almost stuffed that one up. Nice one. Okay. Okay, just because I can't see doesn't mean I'm on. I swear, on God. So here it says find the exact value of for which g of x is a maximum. Rashab, how can I find when g of x is a maximum?
Derivative equals 0.
Yeah, is there another way we can do it?
F max on the cas.
We can use it. Yeah, we can use f max on the cas. Yeah. So here, I want you to avoid using diff too much for trig functions specifically. Wait, what is this? Oh wait, no, it's g of x. Actually, f max won't work. What's another way we can do it? Actually,
Can you just graph it and then do the max point?
yeah, but that will give you decimal place. So here, right? I want you, like, the reason I've asked you this is I want you to come up with the collective ideas of what you could do. So you could do the derivative. You could also do the f max. You could also do graph it, yeah? And it's just whichever form they wanted it. If they wanted decimal places, I just graph the function. If they want exact values, well, you have to differentiate. So here, we'll do 3, 1, 0 equals 4, 1, x, g of x outside, comma, x, yeah? So this is just saying, find when the derivative of g of x equals 0. And we're given these two functions. Now, which one of these will I choose? Salam. Which one of these will I choose?
Is it the -2 √3 minus 3 on 3?
Yeah, so you can choose that. Like, the reason I would choose it is because I click Control Enter and I'll see that the first one is actually the smaller one. Yeah? So this usually goes from smallest to largest. So here, what we'd say is we just... Who's trying to join? Emeth, you don't have to be here.
No, I just want to see what's going on, bro.
Dude, you don't even do methods. Okay. God forbid.
No, I'm just a curious man, bro. Let me see
Okay.
what's going on.
Wrong maths, bro.
Yeah, wrong maths, bro. So here, the first thing that they want you to they'd probably want you for working out to do is they'd want you to just say so g dash of x equals, you know, whatever the derivative of this function is, so we can differentiate that pretty easily. It's just 3x squared, take 12x plus 8. Then we just do g dash of x equals 0, hence x is going to be equal to whatever we get on the cas. So we get here -2 √3 take 3 over 3, or 2 brackets √3 plus 3 over 2. Hence, we just say x is equal to, low key, I'm just bored as fuck. I miss methods. So x equals -2 √3 take away 3 over 3. Do we need to do anything else, Rishab, to like for us to say it's a maximum?
No.
you have to
You just
discount.
prove it.
Say it again.
You just prove it.
No, you don't need to prove it. You just need to say as x equals 2 brackets root 3 plus 3 over 2 is the minimum. Yeah? You don't need to prove it. You just need a reason to discount it. Yeah? So if you're going to discount a solution, you need a reason why you're discounting that solution. Yeah? You know, like how we have like sometimes you get e to the x equals like -1 and we discount it because like e to the x is greater than 0. Yeah? We need a reason to discount it. Through that. So, I'll ask Swayan, how can I write the shaded area of this function?
You just do upper minus lower
Yeah,
and the integrals for it.
so here, so what would be the integral for this first area?
0, 1, or 1 at the top, 0 at the bottom.
Yep.
And then it would be like 2 and 1. And then 3 and 2, and then 4 and 3.
Yeah, so
2 and 3 and 3 and 4 are negative. Right?
So here for bounded area, we actually don't have to worry about the negatives, yeah? We just have to make sure we choose the right top function and the bottom function. So what's going to be the top function for this first one?
Gx.
So g of x, and then that means f of x is the bottom function, yeah? What about in the second integral? What's the top function?
Fx.
Yeah, f of x, take g of x, dx. Right, what about down here? What's the top function? What's the bottom function?
I think it's Gx.
Yeah, so g of x is the bottom is the top function here. So we have g of x, take f of x dx. Yeah? And here, what about this one?
Is it Fx again?
Yeah, fx, take g of x dx from 3 to 4 is our bottom function. So here, you don't actually need to worry about... So for bounded area, if you do the right top minus bottom, you don't need to worry about bounded area. I'll say that now. You don't need to worry about bounded area. I mean, you don't need to worry about signed area for bounded area if you do the right top minus bottom. If you stuff it up, then you will. Yeah? Just told you I'm not here. Okay. So then here we get a equals the integral from 0 to 1. We get g of x, take f of x dx, plus the integral from 1 to 2, f of x, take g of x dx, plus the integral from 2 to 3, g of x, take f of x, plus the integral, so remember the dx at the end, and then so dx, and then plus the integral from 3 to 4, f of x, take g of x dx. Yeah? So, now, try and find the total area and write that in your, well, write that one on your, what's it called? Right, tell me what the final answer is in the chat. What's up, Swaya?
So is it for bounded area? You don't consider the negative,
Yeah, bounded area you don't need to consider negative.
but for signed area you do, right?
For if we wanted to, let's just say, like find the if we needed to find the area between the x, like let's just say with this parabola here, and we want to find the signed area here, we do have to care about it. But for bounded area between two graphs, you don't.
Okay, thank you.
So, what do you guys get as the answer? Ah, come on, Rashab, you didn't define it. You're so lucky I've written it all up here in immaculate detail. There's another way you can write this. I'll tell you in a bit. So we have here one. What the hell are you guys on about? plus 4, 3, 2. Dude, can you guys just do the question, please? Oh God. There's just a whole bunch of yapping here. No more Monash then, gang. So, what did you guys get as the final answer for this one? What did you guys get as the final answer for this one? 2! Yes, 2. So you get 2 as your final answer. If you type that whole thing in, you get 2. The other way you can do this is you can realize that these two areas are the same as these two areas. Yeah? Right? And then you can instead just do these two integrals here, so these two here, and then times them by 2 to find our total area. Yeah? Our total bounded area. Does that make sense? Thumbs up, thumbs down, thumbs to the side, thumbs all around. Okay, Sham, chill. Don't worry about this one. I need to fix this sheet soon. Despite how easy I hate this. Okay, I'll leave. I low-key don't want to disturb methods. It's a hard subject. Look at Emeth being so noble. So, here we have the area bounded by the y-axis, the x-axis, the curve y equals e to the power of 2x, and the line x equals c. So, Rishav, how can I sketch this area?
Like draw the graphs.
Yeah, so I'll draw the graph. So here is the graph e to the x. So here, and c is a positive real constant. So my bounded area, what it wants, is between the y-axis, the x-axis, this curve, and the value of when x equals c. Yeah? So I want this area. That's what it's telling me. Yeah? So Swayam, how can I write out an integral to solve this one? Right? Start off with, how can I find an integral to find this value of c? That's the question I asked.
Wait, can you like ask it again? I just got lost.
How can I use integrals to find the value of c?
It isn't when x equals c, isn't that just the x-intercept?
So x equals c isn't an x-intercept, no.
I don't know then.
So we get here 5 over 2 equals the integral from 0 to c e to the 2x dx. Right? So we get 5 over 2, which is what this area is equal to from 0 to c. These are our two boundaries. Yeah? Does that make sense, Swaya?
Is it just c because the line x equals c?
Yeah.
The integral?
Yeah.
Yeah.
So that means here we get 5 over 2. And we get here, what's the integral of this function? Salam. What's the integral of this function?
Would it be 1 on 2 e to the 2x?
Yeah, so e to the 2x. Yep, yeah. So that means we get it from c to 0, yeah? And then we can use our fundamental theorem. So we have here, that means 5 over 2 equals f of c, take f of 0. You get f of x equals e to the 2x over 2. F of 0 equals e to the 0 over 2, which is just a half. we get f of c equals e to the 2c over 2. And now we're just left with 5 over 2 equals e to the 2c over 2 take a half. How can we solve this one, Rashad?
Wait, can you say that again?
How can we solve this one?
Um, like for x or
For C.
obviously like plus the 1/2 the other side.
So we get here 3 equals e to the 2c over 2. Yeah?
Then times the 2.
Yep. So 6 equals e to the 2c.
Then make it a log.
Yep. So ln of 6, 2c.
And then divide the 2.
So we get here ln of 6 half equals c. Does that make sense for everyone? Okay, perfect. So, another average value question. Have a go at doing this average value question. Let's see how you guys go. What do you guys get for the average value of this function? And I'll race you guys. I'll do it by hand. You guys have to do it. You guys use your calcs, I'll do it by hand. One, 0, 2, 2. Also, you don't have to know the method that I'm doing by hand. I'm just doing it to see who I can beat in a race. Fuck. Dude, that was so fast. This isn't fair. I'm actually losing and I can't even do anything about it. Ah, bro. Oh my god. See, isn't the calculator so much faster than doing it by hand? There's a point to learn here, and it's not me who's going to be making the point. Anyway, I won't worry about doing it by hand. Yeah. Alex brain got mugged. Exactly. Yeah. That's what I'm going to tell you guys. Did you see how, like, even though, right, I can do this by hand. Yeah. If I told you guys to do it by hand, you guys, like, if I taught you how to do it by hand, you could do it by hand. But why the hell would you want to? Just use the CAS. It's right there. Like it's like when people are like for fun, bruh. Do you know? You get here 4, 3, 0, 2, 2. You don't need to be able to know the integration, like the actual integration technique. Yeah. 3x plus 1 dx. And here we get answer option D. So, does someone want to have a go at this one? Who wants to go at this one? Rashad. Have a try at this one. So it's hold this integral, yeah? How can
Yeah.
I make this integral out of this expression?
By like turning it in, like transforming it.
Yeah, we can transform. Oh yeah, we can do transformations. Do you know how to do the transformations?
Nah.
No? Is there some way we can break this integral up?
Take the 2 out.
Yeah, we can take the 2 out. Is there something else we can do? What do we do for integration by recognition? You remember that I distributed the integral?
No.
So like I can distribute it like this. Yeah?
Yeah.
And then I can factorize out the 2. So I can get here 1, 3 f of x dx. Take the integral from 3, 1, 3 dx, yeah? We
Mhm.
know this integral is equal to 5. So we just get 2 times 5. And what's the integral of 3?
3x.
So we get 3 over 1, yeah? Or, if you want to think about it as areas, we can think about it as, what is the area of just this rectangle? Because that's what this represents. It's just the area of the rectangle. What's the area of the rectangle that goes from 1 to 3 and has a height of 3?
6.
6. So we get 2 times 5, take 6, which is, what do we get?
4.
4. So, here, right? Sure, I used integrate. I actually didn't really use any integration there. Yeah, I just remembered that integration is the study of areas. Yeah, I remembered that integration is the study of areas. So here, if I want to evaluate this area, right, why waste the time doing all this integration when I can just look at a rectangle? Yeah, I can just draw a rectangle out and realize, oh, okay, well, it's the rectangle. I just have 2 times 5, take away 6. Because if I did this by hand, I'd have to do the f of 3, take f of 1, right? And then we just realize, oh, well, we know that f of x is equal to 3x, which means f of 3 is 9, take away, we get f of 1, which is 3, which is just 6. Yeah, so we get the same thing, yeah? It's always finding out which way is the fastest. Being a mathematician is all about being as lazy as possible. Being as lazy as possible. Maths really overcomplicates life. Not really. It's like speaking another language. It's great. So, here, the graph of the function f is shown below. The graph of the antiderivative of f could be. So which one could be the graph of the antiderivative of x, of f? So basically, which one of these could be capital F? And I know when I do the fundamental theorem, I've switched over to doing capital F, yeah? So, Sharp says B. Anyone else agree with him? Islam says C. Has he? I don't think I've shown Rashab the sheet before. So yeah, the answer for this one's B. Yeah, it's not A, and it can't be C, and it's definitely not D. Yeah, the reason it can't be A or C is because there's turning points here, but there's no point here where the derivative is equal to 0. Yeah, so it must be between B or E. E has a negative gradient consistently, whereas A has this positive gradient consistently. So that means here, right, f of x must be just B. I just looked at B has a positive gradient, so the derivative is positive. I know, I did it with Jerry and Carl. So here's this one here. Let's see why this is part of. Oh, that's why. Oh, no. Anyway. So, it says here, the graph below shows part of the graph of the function f of x, where x is a real positive value. F of x equals 7 over x. The line segment CA is drawn from 1, f of 1 to a, f of a. Calculate the gradient of C of A in terms of A. So how can we determine the gradient of this graph? I'll ask how can we find the gradient of this graph?
A rock. So
Yep.
it'll be f of A, or f of B minus f of A on B minus A, and B is equal to A in this case.
Yeah, so we have here f of A, take f of 1 over A take away 1. So then what do we get as a, if we simplify that, what do we get?
f of a take away 7 on a minus 1.
So yeah, so we get 7 on a, take 7 over a minus 1, which is just, if we simplify this one, we just get here 7 take away 7a over a brackets a minus 1. Now, this is an exam too, so I don't expect you guys to do this using by hand, yeah? But that's the first part done by hand. You can do that first part pretty quickly, yeah? Then it says, at what value of x does 1 and a, at what value of x between 1 and a does the tangent have the same gradient as CA, yeah? So how can we find out when the tangent has the same gradient as CA? Any ideas? Any thoughts? Any thoughts from anyone? Any ideas? Yo, what's up, Salam? Hit me with it.
Isn't it you do the derivative of f and then at x equals 1 because it goes through 1, and then and then you find that's the gradient for tangent, right? And also the graph.
So calculate this in terms of a. For what value of x between 1 and a does the tangent to the curve have the same gradient as c? So no, not quite. So here, what we do is, let me screen share the whole screen. I have here my f of x, yeah? And I already know my a rock. It's going to be down here, yeah? I simply just so I do simply 3, 1, 4, 1, which is the derivative. What's a rock? The average rate of change. That's what a rock represents, the average rate of change. I forget I don't teach you for methods. I teach you for chemistry. Over 7 take 7a over a times 1 take a, comma, because that's the phrase they use in the exam. They use a rock, comma, x. So you want to find out the value of x. Well, it says x is either between is negative square root a or x equals square root a. So essentially what I can do is I can write down my f dash of x here, which is just negative 1 over x squared, and then I do f dash of x equals 7 take 7a over a brackets a take away 1, and hence I get a equals plus or minus the square root of a. Is that my final answer, Bashab?
No.
No. What's my final answer?
Um, X equals. Um, I wasn't really listening to that part.
It's the square root of a. It's the positive square root of a, because it can't be the negative one.
Alright. Yeah.
Well. Rashab's lost the plot now. So, Swayham, does that make sense what the average rate of change is, though?
Yeah.
Okay. So, how can I evaluate this integral real quick on my good old friend? My good friend, the CAS calculator. So tiny. Hey, your good old friend, the data book. Trust. Yeah, our good friend, but not our best friend. Yes, incredible call. Incredible call from you guys. Holy shit. So how can I evaluate that integral? So, does anyone have an answer for me? What's up, Salam? What's the answer?
Can't you just do menu 4-3 and then like you do it from there and you sub in the f of x and that? Yeah.
Yeah, you do menu 4-3. Yeah. So it is 7 in 7 ln of e. Oh wait, Swayam. You made a mistake that all of us have made one time in our life. Yeah?
What is it?
You didn't use special letter E. You used
Oh, that's
regular E. Remember?
I forgot about that. My bad.
No, don't worry about it too much. Don't worry about it too much. Just like always remember, everyone, don't trust this E on the calculator. When it says E, it needs to be bolded, right? It needs to be bolded, highlighted. You need to put glitter on it. You need to, I don't know. What's something else?
How do you get that E?
Do you have the black calculator?
Yeah.
So there's two ways. You can either use E to the power of 1, or you can go back down to here, which is that little pi button, yeah? And if you click the pi button,
yeah.
to navigate across it, you just click the pi button multiple times, yeah? And then,
Yeah.
whichever one I want, I can just hit this. Does that make sense?
Yeah. Thank you.
And Salam, how'd you get 7 over E?
Don't you have to put the 1 on e minus 1 to the left of it? Like how on the one before you put this thing to the side, like 1 on thingy, like that formula from the formula sheet, I think.
Oh, no. That's for the average rate of change. We just want to evaluate the integral here. I mean, no, not average rate of change. The average value, yeah? So we have the average value, yeah? You're talking about the average value formula. This is just evaluating the integral. Wait, on that subject, you scammed me. If I type dx on the calculator, it's the same. What do you mean? Is it? No, it's not. I swear it's not. This is a different D. This is a different D. I told you this is a different D. You have to use menu 4-3. Why are we lying, Joe? I've told you this before, Joe. No, it's not. No, it's not. Why are we lying? No, it is. It's a different D. You can't write. You can't type in. I spoke about this with Joe the other day. You wanted to type this in, yeah? It's not the same as literally going menu 4-1. It's a different letter D. Like the cousin's coded in such a way it's a different letter D. So the answer for this one's just 7. Here it says let B be a positive real number less than 1. Find the value of B such that the integral from B to 1 dx is equal to 7. So how can I do this on my calculator? Let me screen share the right thing. And why did the anti-diff normal D instead of... What? Dude, it's a different D. I swear, it's a different D. Don't worry about it. It's a different D. It defines it using the D. So how can I do this one? Mia, how can I do this one? How can I find when the integral is equal to 7?
I don't know.
Okay. That's fine. That's fine. So we're told that 7 equals the integral from a1 f of x dx. I'm just going to say this now. Yes, we can literally type that whole expression into our CAS and put it into the solve function. So here, we go menu 3-1. Here we type in 7 equals the integral that we want. So 3-1, this is from b to 1, 7 over x dx, comma, comma b. We can literally type this exact phrase in, yeah? And because we want the positive solution, it's just going to be b equals e to the power of -1. Does that make sense to everyone? Any questions about that? Any questions? Any comments? Any concerns? It's all good for Salam. It's all good for Swayam, Shab. Okay. It's all good for Joe. It's all good for Mia. What about Daniel? Oh wait, Daniel's thumbs up, thumbs down doesn't look like this isn't working, is it? So here, right? We'll keep going down. We'll keep going down. We'll keep encountering Lord Calculus and his calculus-filled voodoo. They learn tech so fast, don't they? Okay, bro. Okay. God forbid. Why are you guys so mean to me? Anyway, so here it says express the area of the region bounded by the line CA, the x-axis, the line x equals 1, and the line x equals a in terms of a. How can I find the bounded area between these two? Swayam, how can I find the equation for the line CA? This might be the only place I can watch a tutor get flamed. This shit. Yeah.
Wait. I just froze. Wait, what was the question?
How can I find the equation of the line CA? Because it wants me to find the bounded area between the graph and the line CA.
You no, I don't know.
So think back to it. We get y take y1 equals mx take x1. Yeah?
Yeah.
We know m. We found m. We found m in our first part. Right? We also know a y1 and an x1. So we can just leave it as y take f of 1 equals 7a over a take away 1 brackets a x take 1. Does that make sense, Wayo?
Yeah.
So I found this equation of the line, yeah? Now it says find the expression of this equation from the region bounded between this, the line. Okay. Find the region bounded between the line segment. Oh no! I've misread this one. So it's meant to be from 1 to a. Ignore the axis. It's just this. It's this whole thing. Yeah. So I need to find the area between this whole thing, which means if I just find y equals right 7a over a brackets a take 1 brackets x take away 1 plus f of 1, yeah, I can just integrate that between 1 and a. Yeah. I don't need to simplify that myself. I have my calculator, my best friend, right? I mean, not my best friend, my bad. My second best friend. So I say a equals the integral from 1 to a, right? Nice save, Unc. Thanks. No problem. But I'm actually just gonna I'm just getting flamed, bro. It's not nice, bro. Plus f of 1 dx, yeah? So then we can go into the calculator. We can go menu 4-3. We can type in 1, comma a equals, and we're just gonna type in that whole expression. So 7a. Oh wait, no. 7 take 7a. Oh yeah, where's my calculator? My bad, gang. Am I just gonna get the nickname Unc for the rest of my life? Am I just gonna suffer with you guys? So times by 1 take away a. Or 1 take away a, or is it a take away 1? Let me just check. it is a take away 1. Let me write this properly. So this is actually a take away 1. So here a take away 1 brackets x take 1 plus f of 1, and we get here dx. We'll get this as my expression, which doesn't actually look that bad. Yeah, I get here 7. Just write this whole thing down. Put the calculator on the screen for a second. 7 3a squared take 4a plus 1 over 2a. And then the final question asks me, for what exact value of a does this area equal 7? So this here is my expression for the area, right? I can just do 317 equals, and then I can just plug in the value of a. I can just plug in this whole system and then solve it. And I get these two. And I'm going to check which one's positive. So here, I get both of these values. So I can say a is equal to, wait, what's the exact value? A is equal to 3 plus or minus root 6 over 3. Don't worry, this is a season. Tis the season. Okay. And the question continues. It continues. It says, so here it says for what exact value of a. So here I've got 2 solutions. I can only pick one though, and here the answer is just going to be 3 plus the square root of 6 over 3. The reason this one's the answer here is because, right, it has to be greater than, it has to be like a has to be greater than 1 here. I can't have it be less than 1. That doesn't make sense. Yeah, my integral wouldn't make sense then, because my integral should then be negative if it was that. So does that make sense for everyone? Any questions? So now it says here, using the value of a determined in part C, explain in words without evaluating the integral why a over 1 f of x dx is always less than 7. Use this result to explain why a is greater than e. Ooh. Anyone have any ideas? Anyone have any thoughts? Can't evaluate the integral. So this is my value up here. So we can use our answer from CI. So let's say A is less than. Explain why. Use this result. So here, right? Go on, Salah.
Is it because you used the line before? You used the line CA, but this one is saying f of x, not that line.
That's a good.
So an f of x is lower, so it'll be less than 7, right?
Yes, yes. So here, right? This. So we're using our value from CII to explain why a between 1 f of x is less than 7. It's because, right, as Salam said, this area from C to A will always be greater than will always be greater than the area under the curve. Yeah, because we're talking about the integral of f of x. So that's why here I have no personality and I must laugh. I still don't know what laughing is, bro. So yeah, that's a good response, Salam. Yeah, that's good. That's good intuition. So here, if I wanted to explain that out with words, you say the line CA is always going to have a greater area than f of x, right? So that this is the explanation, and then it says use this result to explain why a is less than e. If a is greater than or equal to e, then the integral from 1 to a f of x dx will be greater than or equal to will then be greater than or equal to 7, as shown in part B, right? Because in part B we show that it'd be equal to 7, yeah? So does that make sense? This question's a bit brutal, and it keeps going. It says find the exact value of m and n such that this is true. I'll ask. This is the last question we do. Sway m. How can I do this question? If you don't know, that's fine.
How can you do it? Do you just put it into your calculator and press algebra solve? It's like systems of equations.
Yes, it's two equations, two variables. That's perfect. That's exactly right. So we get here 3, 7, 1. We want to find here. So if I was navigating this on the CAS, I'd use my tab button. So here, tab on the CAS to navigate. Don't use any other button, because if you click down, it would mess it up. Then we'll do here m, comma, n. And now what I want to do is I literally type in the whole expression that I got given there. So I get 1 m n times n. Remember to put the times between them, or else the CAS will think you're talking about mn. Yeah, I think I've spoken about the Python software with you guys a couple times. So then we type in f of x dx, and this thing equals 3. Yeah, so this thing equals 3. Then we do the same thing. We do here, not control, menu for 3. We do here 1 from m divided by n, f of x dx equals, right here, and this one equals 2. So let it equal 2, and we get these values for m and n. So he says here, find the exact values for m and n. So here it says, right, we literally write down m equals negative e. Oh wait, no. Oh yeah, that works. So e to the power of 5 over 14, n equals negative e to the 1 over 14, or right, if we go across, I'll just click Control Enter. Right, we can have, oh, there's so many solutions. There's so many solutions. We can't have the negative ones. We'd have essentially 4 sets of solutions. So we have to write down, here we'd also say, or m equals negative e to the power of 5 over 14, and n equals 1 over 14. Or we say here m equals 5 to the e to the 5 over 14, or n equals negative 1 over 14, or m equals 5 over 14 and n equals 1 over 14. Yeah? So look at how many solutions that we have here. Isn't it incredible? Isn't there so many? There's 4 sets of solutions here, right? And that's why you don't do this by hand. If you did this by hand, you'd want to explode. Damn. All those solutions just for 2. All those solutions just for 2 marks. Exactly. Yeah? Gotta love maths. So, I'm going to end off today, right? This worksheet has questions that go from 2009, Here's 2010. Here's 2011. Here's 2012. Here's 2013 over here. 2014 is down here. 2015 afterwards. You know, there's plenty of questions to pull from. There's so many integration questions. There's so many, right? And here, you can find all of these ones on, I've just had this in the background. Math really be crazy. All of these can be found on the Dynamic Education website. Please remember the link, dynamiceducation.com.au/4friends. Did that just... Okay, I thought my Chrome just crashed. And you can find these 2 worksheets right here. There's a bunch of questions. And I think my Chrome just crashed. And I think my PC just crashed. And I think my PC just blew up. I think my PC just fucking blew up.